All right. So I'm live streaming it into YouTube also, so that those who are not able to uh, know what is going in the class can watch it later. All right. So let's get to business. So this is CS606 programming paradigms. Okay. And what is this course about? I Many people had the confusion. What is this course about? And let me just start with a very simple, not this one. Yeah, let's look at a picture. There are thousands and thousands of programming languages, but if you look at language, just like in the case of normal languages, we can classify programming languages also. Yeah, can anybody tell me some ways of classifying programming languages? Hello.
Compiled versus interpreted.
Yeah, so compiled versus interpreted, that is one way of classifying. Any other ways of classifying?
Object oriented.
Object oriented versus what? Object oriented versus, we can say non-object oriented, but object oriented versus, it's not a binary classification. Yeah, it's a approach oriented classification, the way you solve the problem. So yeah, so we have already two ways of classifying. So there are many ways of classifying programming language. I could classify in terms of the programming style. For instance, um, programming languages like C, C++, then Go, then C sharp, all of them have the same style, in the sense that they have the same, they use the same symbols, braces for opening a this thing, and so on. So I could call that family as C family, because they all follow the same syntax. So I could classify based on syntax. I could classify based on uh, how high level the language is. C is very low level. We will really understand what is this low level, high level, etc. All these things. So this is a course about not about individual programming language, but how if so everybody understands that you can't just live with one programming language. You will learn one programming language today, but you, in 10 days, in 10 years, there'll be another programming language which is hot in the market. So you'll have to learn that programming language if you're going to do programming in computer science. Yeah, programming. Now the question is, we can't teach that 10 years down the line programming language today. So you will have to learn it tomorrow. Now the problem is, how do one equip people to learn programming language? That's a skill we want to acquire. We want to acquire the skill of learning new programming languages. Okay. All right. It's very difficult to talk without somebody, getting a response back. And it's not your fault, but I can understand because it's a huge class. Yeah. But at least some of you can unmute your mic. It will be helpful for me. Aditi?
Yes, sir.
Yeah. And two more. Could you please volunteer some two more people so that we can have a conversation? Devang and yeah, and Hasher, you also unmute. You also unmute and keep. All right. Okay. Yeah, that's enough. Yeah. Okay. So now it's your responsibility to answer my questions. Yeah, when I ask something. Okay, somebody, Jared said type safe versus type unsafe. Yeah, all these are ways of classifying programming languages. Now, what do we really mean by programming paradigms? So, to understand that, we have to understand what is paradigm. Yeah, have you heard this word before, paradigm? In what context did you hear the word paradigm? In
Sir,
what, yeah, in what context did you hear the word paradigm?
sir, in competitive coding, there are different types of paradigm. For example, a problem can be solved using divide and conquer, or we can use a greedy approach, or we can use dynamic programming to solve a problem. So these are different paradigms or different ways to approach a solution for a
Okay,
problem.
so yeah, all right. I mean, it's a fair use of the term in that context. Paradigm usually means interconnected set of ideas. Okay, uh, pa- in the sense that when I talk about procedural paradigm or object-oriented paradigm or functional paradigm, these are all different ways of looking at a problem. I'll give you an example. Imagine you want to build a computer system for an airport. Okay, I want to handle so I want to build a software for managing a particular airport. Let's imagine we are only managing the people side of things. We are not managing anything but the aeroplanes and so on. We are just managing bookings and luggages and all these things. Okay, so in that case, we could do that approach that problem in several different ways. One approach is like this. One approach is to actually think of the data structures involved in building such a system. I could say uh, booking is one data structure where I will say booking is I mean, obviously linked list is not a very good idea for booking. uh, so basically imagine I want to store the information like passenger name, flight number, and luggage number or something like that. Some 3 4 data elements: passenger name, booking number, flight number, luggage number, and so on. So whenever I want to look up, I have this for these things, and I can look up this thing. Now, what will be an ideal data structure to represent? I mean, to store such elements. Get my question? Hello,
Yes, sir.
Ashir. Yeah, what is a good data structure? I mean, any data structure is fine, no, provided it is not too bad. Because I wouldn't like we can't use linked list for that. Why?
Sir, because accessing different elements will take a lot of time.
It will take a lot of time, exactly. But even array is fine, because then you can use binary search to find out which one is the best. Yeah. But ideally, you would like to have something like a hash table, because a booking number will be a unique identifier. And so usually when you go to an airport, or the first thing they ask you to enter is either booking number or and your name. These are the two things which they ask you to enter to print out your pass. Yeah, what is it called, isn't it? You remember?
Yes.
When you go to airport and you want to print out your boarding pass, the system asks you to enter your booking reference number and your name. These are the two things they ask. So obviously, these are the two things by which you are going to access most of the data. So a procedural guy looking at going to make a software for an airport will think of data structures first, and then think about functions which can modify and update these data structures. That will be his standard way of solving the problem. Yeah? So he will represent the passenger information in one data structure, the luggage information in another data structure, then the flight information in another data structure, and then he will have functions which will which will update these data structures and add elements and delete elements and so on. This will be his approach. It's a very good approach, but there are easier approaches. Another approach is the object-oriented approach, in which the idea will be to actually think of each passenger as an object, each luggage as an object, each flight as an object, and a passenger object will contain its own booking reference number, its own name, its on luggage ID, its on flight ID, and so on. Similarly, each flight will have its own set of features, and each luggage will have its own luggage ID, its own passenger ID, its own flight ID, and so on. And then what we will have is functions. Each object will have its own methods. Yeah, passenger will have its own method to find its luggage ID, to check in in a flight, and so on. And we will model the whatever is going on in the airport as the ways in which these objects interact. You get what I'm saying, Deva?
Yes, sir.
And this is the second approach in which you do this is object-oriented approach in which you can solve a problem. So you have already seen two, and I'm pretty sure that you are well versed with at least, I mean, the first approach, the data structure approach, because typically when a student enrolls for a course in computer science, they do a basic programming course, and then they do a data structures course in which the first approach is emphasized. In the second approach, we expect that it's very common these days, because it's not because the approach is superior. It's just that it is much easier, and it allows division of labor. Yeah, because programming software is a huge task, and typically it is divided between lots of people. And in companies, there is a problem that people will come, join, they'll work for some time, and then they will leave. So the the software has to be understood by other people who come to program. So therefore, the division of labor has to be smoothened. And that's why object-oriented approaches have a superiority in that sense, in the sense that you don't need the same person to be involved from the beginning to the end of the programming process. You can always get in the middle and start doing stuff. So, but that is a certain advantage of object-oriented style of programming. Now, so these are the two programming styles we are familiar with. Now there are other programming approaches called functional programming style, and another is called logic programming style, and so on. There are many. Yeah. So in a second.
Hello.
Yeah.
Okay. So the purpose of this course is to get familiarized with these programming approaches. Now, the best way to do that is by learning some programming languages. Okay. And so there is a programming language called Lisp, Lisp. Okay. Lisp is the second oldest programming language which is still in use today. And why Lisp? Let me. Okay, can you see my screen?
Yes, sir.
Sir.
Okay. So this is the 2019 Stack Overflow survey, okay, in which they asked people about what are the technologies they use and so on. Okay, so what are the most popular technologies? Programming languages, you could say programming languages. The most popular is JavaScript, HTML, CSS, SQL, Python, Java, C Sharp, PHP, C++, and so on. Okay, and it comes, and then there is Rust, Dart, etc. Most popular. But if you look at the top paying technologies, yeah, which is a very important one, the first is Clojure. Clojure is a Lisp language. Lisp has so many dialects. You can see it here. Okay, these are programming language families. Okay, this figure I'll upload it in the 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 website which we are going to use. These are programming language families. So if you come here, we have our C language family here: CPL, BCPL, BC, Aleph, Cyclone, LPC, C++, Objective-C, Py, D, etc. This is the C family of languages. Similarly, there is a huge family of languages called Lisp. This is Lisp. And this is the second oldest programming language which is still in use today. The first programming language which is still in use today is Fortran, which is not very popular in computer science, but in scientific computation, it is still popular. So Lisp have so many dialects. All of them are called Lisp again. You would say uh, Scheme is a Lisp, which means that Scheme is a dialect of the Lisp, because Lisp family has a certain peculiarity that all of the Lisps have syntactically look the same. Okay, their internal details might be different, but syntactically they are all the same. So we will learn this language Lisp scheme in this course. But my point was that Clojure belongs to Lisp family. Similarly, F sharp belongs to another and Lisp is a functional paradigm. Okay, functional paradigm. We will understand what is functional paradigm later on. But that is one of the main purpose of our course. We will learn all these paradigms through one language called Lisp. Okay, more about that in a few minutes. And F sharp belongs to a family called ML. F sharp is here. ML is uh, this family: ML, standard ML, dependent ML, and so on. Actually, this family is also sometimes people consider it as part of ML. ML family. Then Go is not exactly. So Clojure is functional, F sharp is functional, Scala is a functional language, Elixir is a functional language, and Erlang is a functional language, and so on. So you see that even though we are more familiar with uh, procedural and object-oriented functional programming styles, functional styles are much harder, but at the same time they are top paying. Okay, so that is one strong motivation for learning functional programming. Okay, the best functional programming is still, I mean, my favorite functional programming language is still not in this list. It is here, my most popular language. It is not here either. Let me see. Most loved, dread. Most loved. It is not there either. Most dreaded. Oh my god, it's not there either. Wow. So it has the name Haskell. I taught that last semester. Let's see if it is here. It is not here. Okay. Anyway, Haskell is probably the best programming. It is an industry, I mean, academic standard for functional programming. But the problem with Haskell is that it is a bit tough, and I wouldn't go on in a semester like this. I wouldn't go on teaching that. But I will definitely teach Haskell to you guys in a couple of semesters. But learning Lisp is another important milestone we have to achieve. Okay. All right. So to summarize whatever I was saying so far, that there are multiple paradigms of programming. One is procedural, which is in for the languages. For instance, when you program in C, when you program in yeah, C is the quintessential. Quintessential means that something which is truly representative. Quintessential procedural language. Pascal is also another quintessential procedural language. Maybe Pascal is a little more uh, uh, in academy, at least Pascal is considered to be more procedural than C. Then C++, Java, Python, all these are object-oriented programming languages. And then the third, there is a functional programming language style, which are Lisp, Haskell, Clojure, Elixir, Erlang. Erlang is Ericsson language. Ericsson is a mobile company, so they for almost all of their devices or telephonic devices uses very simple functional language. That is what is Erlang, Ericsson language. Erlang. Elixir is Elixir is again ML family, I think. Clojure is Lisp. Clojure is built on Java virtual machine, on top of Java virtual machine. That's why it's, uh, it's more famous. It's more popular than the others. You can see that significantly higher. Okay. All right. All right. So now, what are we going to do in this semester? Because this there is a his there is a course called Structure and Interpretation of Computer Programs. Okay. Now this used to be the first course for somebody who is taking computer science in MIT. Okay, whoever comes, it started in 1970s, and it continued till 2015 or so. It was the first course anybody who is taking computer science has to take this first course. But you have to understand that in MIT, when you come and join a computer science department, you don't start taking the computer science courses immediately. You have to do a couple of years of preparation before you start taking your own important courses. So by the time you reach this course, they are at a significant level where they will be able to understand a little more. Now in this course, what they are actually doing is that they are teaching a list called scheme, and in that, through that scheme, they teach all programming styles. They will teach object oriented programming, they will teach procedural programming, they will teach what is status abstraction, and they will teach what is functional programming, what is logic programming, etc., through this one language called scheme. And we are going to do exactly the same. And the book is it has a cult status. This has a cult status. I remember when I was a bachelor student, during the third year of my bachelor's, I was doing an internship in Bangalore, and that time, the first time I saw this book, and the lecture videos were also there in the web. These days it is there in so I have created a web page for our course here. I'll share it with you. Um, the course videos those days were available in on the web, and so I watched these things. I didn't understand much because there was nobody who could explain it to me that time. It's a relatively tough course. It's not very easy because you are learning a programming language, and then you are learning these concepts as we go along. So that's why it's and scheme has a very simple syntax, so it's not really the toughness of learning the syntax. Scheme syntax, entire syntax will, or the rules of forming the language will fit into a postcard. I mean, it's so small. Postcard is this size. Yeah. So yeah, so those days it was available on the web, not on YouTube, because YouTube hasn't come that time. And I watched this and I was inspired, and then I decided that I won't go for a job, because I was partly disillusioned by the job, by the internship, and I decided that I'll just learn more in this subject, and I proceeded and I did a PhD in this, not in this subject but in logic. Yeah, but it was highly motivating for me, this lecture series, this. And you can see there are many. One second, why is it not coming? You can see in the web why SICP matters. I mean, it has a cult following. This textbook has a cult following. The textbook can be found in many places also, in many translations. Uh, right here. You can see my screen. Hello.
Yes, sir.
Yeah, the textbook is here. Structure and interpretation of computer programs, and then the audio lectures. It still continues in MIT in uh, in uh, in another course numbering. Even though the first programming language has been replaced from Lisp, from Scheme to Python, but they still teach Scheme in another course. Okay, so this course is still continuing, and every computer science major has to do this course. So what we are going to do is that, yeah. So a couple of words more about Lisp. Uh, so okay, so Scheme has a very simple syntax. The point is that you write always things in this format. That's all pretty much to it. Yeah. You want to multiply two numbers, I put a bracket and I put the operator first, and then I put 5 and 6, and then I say it's 30. Okay. And if I want to add 4 and multiply 5 and 6, what will be the answer? Pardon?
Hello, can you hear me,
Wha-
sir?
Yeah, what will be the answer?
34, right?
Yeah, it will be 34. Yeah. And so and everything in the list will be written exactly the same way. And this is all that there is to it. I mean, if you want to define a function, you will define it like define add one, which takes and this one. Can you can just see that I have defined a function which says that define add one x, which will actually, this expression add one x is nothing but plus x1, and then I said add 1 6, and then that is 7. So this is, I mean, that is just to give you a taste of the Lisp syntax. Okay, and you already see that it's not at all difficult, but with this simple syntax, we will be able to do a lot of advanced things, and that is the magic of this book. Okay, now, so what we are going to do is this. We have the two objectives. Now let's come to the core, what we are going to do this semester. So we have classes every Monday and Wednesday for 1 hour each. These 1 hours, what we will do is that we will either do quizzes. So quizzes won't start. Let's first come to the evaluation part of this one. Yeah, so throughout this semester, what we are going to do is that we will read this book and we will watch the lecture videos. That's our primary purpose. Okay, we will read this book called Structure and Interpretation of Computer Programs, and every week I'll say this is the part you have to read, and these are the two lecture videos you have to see. And then you will watch these videos and you will read that part of the book, and then you will come, and Monday and Wednesday we will do these live sessions in which we will either do lab or we do a quiz, quizzes will start a couple of weeks down the line, or we will do discussions, or we will do presentations. Okay, these are the things which will happen during the class. Okay, now there won't be any midsum and final exam. Instead, what I am planning to do is that every couple of weeks there will be a quiz. Okay, so if we have 14 weeks, that will leave time for some 5-6 quizzes. So there will be some 5-6 quizzes, and that will form a significant part of your evaluation. And the other part will be to come for these two uh, discussions. So that will be on Mondays and Wednesdays. I will take attendance, and when you come for this one, that will be the second part of the evaluation. And because there is a significant number of you in this lecture series, I don't know exactly remember how many, but last count there were around 37 people. So Viva is not an option for 37 people. That's why I can't really take Viva, and we will have quizzes instead. Okay, online quizzes
Excuse me,
using
sir.
Google Forms. Yeah,
Okay.
yeah, please.
Yeah, I got your answer.
Yeah,
I got the answer, sir. I was going to ask in which platform you are going to conduct the quizzes.
yeah. I'll do it in Google Forms.
Okay,
Yeah,
sir.
or in Piazza. This is a thing called Piazza. Okay, so yeah, so the things which you have to do is that you have to watch those two videos, and you have to install the MIT scheme or Dr. Racket, whatever is fine. You have to install scheme, MIT scheme. Okay, you can just install scheme. Scheme is the language which you are going to learn, and then you have to uh, in the first chapter of the book itself, they are going to teach you the programming language called scheme, and then we are going to do advanced things. Okay, and you have to install scheme, and then in the book, as we go along, they will teach you the first chapter they will teach you the language. So you have to work out that code in your machine. I hope everybody has a laptop, isn't it? I don't know if Python, there were some things for running on mobile, but Python, I mean, scheme, I don't know if there is something in which you can run it on your laptop. Okay, so the video lectures are here. It's also there in YouTube, the video lectures, but it is from 1986. It is from 1986. But if you like it, you can watch this also. But one of them you have to watch. Yeah. Yeah, and then there is a there is this piazza.com. I'll share the link with you. So you come and enroll here. We will do the rest of the discussions here. Okay. And I have added already the links there. Yeah. So you have any questions, please ask me now. Hello. Questions? No questions?
So the book cover is very fascinating. So what's the interpretation?
The book cover, what is it about? Let me see the book cover. Yeah.
It's 11 o'clock.
This one, no? This one, yeah. What is it about? Okay, so what is the book cover about? Most programming languages, Lisp has an amazing ability which none of the other programming languages has. Okay, and it is very much tightly um, con Yeah. So, okay, in Lisp, if I want to say a list 1, 2, 3, 4, it is a one. It is a list. Okay, 1, 2, 3, 4. I could actually say quote 1, 2, 3, 4. This is a list. Okay. I write in parenthesis. I write one. Put a, there is no comma. Space is we use space instead of comma. So when I say backcourt 1, 2, 3, 4, that's a list. Okay. But instead, if I write 2, 3, this is a function call. I am calling the function plus with the arguments 2 and 3. Okay. Now you see that there is a very close connection. These two things look the same way, except that this is a plus sign here. This is starting with a number. So the amazing thing about Lisp is that the code and data looks the same. Okay. Whenever you write a program, the program looks almost like a Lisp as a list. Program is a list. A program is also a list. Yeah. For instance, plus for whatever we wrote earlier, so 5, 6. This is a list of list. Okay, it's a list which contains 4 and another list which contains star 5 and 6. So any program is a list of lists. Okay, nested lists. And therefore, Lisp has this amazing ability that I can actually convert between program and data. You give me a list program, I can actually build list programs and then execute them within the list program. I don't know if you understand this thing, but when you did your theory of computation, you were in the last part when you were doing Turing machines and things, so that you were saying that there is a Turing machine which can execute any other Turing machine. And in that, what will you do? What were you doing? You take a Turing machine, and then you will change the final state to initial state. You will add something manipulations. You will change the program and then run it and so on. Yeah. Such kind of things are possible in Lisp. It is not possible in any other language, and that is the reason why we have to write Lisp syntax in this particular form. Any Lisp you take will have the same syntax as I told you, and therefore you within a Lisp program you can actually build list and then execute them as list programs. So that gives you amazing flexibility in the sense that you in the sense that you can actually change the semantics, the meaning of list programs within list programs and so on. Okay, so that is why Abelson and Sussman says that this thing, computer science is more closely related to magic than anything else. So here what you have is that one sorcerer, and this is a crystal ball of the sorcerer, a magician, and he has a crystal ball, and he has two uh, functions. One is called eval, one is called apply. And then lambda is a notation for building functions. You will see what is lambda as we go down. Lambda comes from lambda calculus. Lambda calculus is the first programming language, you could say. It's a very rudimentary programming language. And based on that rudimentary programming language, you can build anything based on lambda calculus. And in fact, modern programming languages like many programming languages, even Lisp and Haskell, all these are based on lambda calculus. Yeah. So the point is that the magician is doing magic, and that magic is the magic of programming. Okay. Yeah.
Okay.
So when you do programming with C and Python, etc., we are so tightly connected with the machine model, underlying machine model, that we often forget that what are the possibilities. I mean, even you can do a lot more than what C or Python provides you. You could build programs from within programs and then execute those programs. You can change the syntax of what the programming language you are writing within the programming language. All kinds of things are possible. But in a very rudimentary programming languages, we don't see all those possibilities. But in languages like Lisp, it is possible. So that is this magic. That is what this front page cover is referring to. That was a very good question. Thank you.
So
Other
can I ask you
question?
one question?
Yeah, please.
In which field currently? In which field this Lisp language is more used?
Lisp
In which
is
area?
mostly used for, like you said, it is top paying technology. So Lisp is not very suitable for writing system programs. Okay, if you are doing high level programming, like, I mean, if you want to manipulate your data, if you want to, artificial. I mean, Lisp core strength of Lisp is artificial intelligence, AI. So Lisp typically, Lisp was invented in 1956, and since 1956 Lisp has been used in artificial intelligence, where you want to build symbolic systems. Lisp programming is not tied with underlying this thing. It is more about symbolic expression, symbolic logic, symbolic reasoning, systems, etc. So artificial intelligence and its associated systems is where Lisp is used heavily.
So other than AI, is there any widely used area?
Other than AI, if you want to build, filters, mail filters, spam filters, all these places where functional programming languages are used. Where any place where you want to mine some information and you want to manipulate information and transform data, all these places, Lisp is very useful. Functional languages in particular are very useful, because if I have a data and I want to chop off some words in C, it is very difficult because I have an array, character array, and if I want to, I have, let's imagine I have a word and I want to chop it into, I have a sentence, I want to chop it into words, and I want to find the most frequently occurring word. Okay, if I want to write a C program for it, it's so difficult. Python is much easier, but even more than Python, in languages like Haskell or Lisp, it's much easier. The program I was saying was that I have a long English sentence, and I want to chop it into words, and I want to find the, let's imagine I want to find the longest word and the most occurring word and let's say shortest word, something like that. Then in Lisp or in Haskell or in any other functional language, it is just a 3-line program or even 1-line program. But in C, it will take a long thing to write it. Yeah. So that is where the strength of functional programming comes in. The word functional programming is that that you will get to know what is functional programming as we go along. Okay, so don't worry about that. Yeah. Any other questions?
Sir,
Yeah.
is Lisp faster in execution than the normal languages like Python and C++?
It depends upon what you mean by faster, because not every programming language is faster in every sense of the word. Uh, uh, see, you see there is a trade-off. There is a trade-off between faster and the amount of code you have to write. Okay. Now, like I said, if you want to, if you have a language, let's take the previous program. Uh, I have a sentence, I want to chop it into words, and I want to find the most frequently occurring word. If I want to write that code in C, if I write that program in C, it will take me a lot of time to write it, but at the same time it will be faster. But I mean, but if you write it in Lisp, it will be almost as fast as or Haskell, it will be almost as fast as C, but it will never be, it may never be as faster than C or as close as C. Okay. um, but the second thing is that the most of the time the fastness of an algorithm is not due to the programming language. Programming language fastness is a very small matter. Most of the time your algorithm, your program takes a lot of time, mostly because your algorithm is inefficient. So if you use better algorithms, or if you use the best algorithm, you have the best time. That is as simple as that. If you have a quadratic algorithm, that is, no matter if you write it in C, it will never be faster than a linear time algorithm written in Lisp. Okay, so fastness is not an option, is not the single most deciding factor. But typically, uh, functional programming languages as close to as fast, I mean, or as fast or close to the speed of a C programming language. Yeah, I would say so. They are not slower. They are not. There is a misconception that all these languages are slow. It is not so.
Okay, sir.
Yeah. Yes. Other questions? Hello. Other questions? How many are there now? 42 participants.
There's a question in the chat.
Yeah. What is the question? Sir, what is Moriturus the Saluto? So whenever you close scheme, they will just throw up some uh, fortune cookie or some Latin proverb. So it is just that it is some Latin proverb. I don't know what is the meaning of that. Moriturus the Saluto. I don't know. We can search that. But typically, when you close list scheme, yeah, Pulvis et umbra sumus. Dust and shade are you. This is what it means. Pulvis is dust, umbra is shade. Umbra is the same word umbrella comes from. Summers means in total. So in total, it is dust and shade. That's explaining human condition. Fortitude in Wisconsin. I don't know. I can just take a guess. It should be fortune. No, I don't know. All right. So that's what that is the last sentence of when you exit scheme. It's just a hacker. This one is very closely associated with the hacker culture, where you break up a system and understand and those. The first you will understand the. Let's close by just reading the first. When we go to the next page. Yeah, so I like this one. So this is really the spirit of this book. Okay, that's why you have to read. I think that it's extraordinarily important that we in computer science keep fun in computing. When it started out, it was an awful lot of fun. Of course, the paying customers got shafted every now and then, and after a while, we began to take their complaints seriously. We began to feel as if we really are we are responsible for the successful error-free perfect use of the machines. I don't think we are. I think we are responsible for stretching them, setting them off in new directions, and keeping fun in the house. I hope the field of computer science never loses it in the sense of fun. Okay, I think that's exactly what I also want to achieve from this course. I want you to have fun, and get that spirit of curiosity about this course. Above all, I hope we don't become missionaries. I don't feel as if you're Bible salesman. The world has too many of them already. What you know about computing, all of other people will learn. Don't feel as if the key to successful computing is only in your hands. What is in your hands, I think, hope is intelligence. And I hope is intelligence. The ability to see the machine as more than what you were first led up to it, that you can take it, that you can make it more. Okay. Yeah, and it is devoted to the spirit that lives in the computer. Okay. uh, all right, so for the next week what you have to do is that I will share this link. You have to enroll in Piazza, and for the next week, let's say I will say what you have to read. Okay, and which videos you have to watch. Okay. Hello.
Yes, sir.
Okay, so then we will meet on next Monday 10:15. All right. I'll share the Piazza link. You join in the Piazza, and then I will give you instructions on what to be done for next week. So today you already had a class.
No, sir, this is the first class.
First class.
This is the first class. And how many classes do you have today?
4.
Yeah, so that is one problem. We want to minimize that. I don't know how much you're going to cope up with the online classes. So we want to minimize the online teaching part. Okay, we want to utilize that time for discussions and doubt clearing and so on. So I'll try to come up with some activities so that you can I can facilitate your discussions between each other, so that you can read this book and discuss between each other. Yeah. And yeah, and I need your utmost cooperation, otherwise it won't work. When I say you have to read this chapter and read this watch these 2 videos, you have to do that before you come to class. Okay. So for the next week, you have to watch. You have to read the first chapter and watch the first 2 videos of the links I have provided here. Anyway, I'll give the instructions later. Okay. So all the best. Yeah, I hope you don't have any other questions. All right. Hello.
Yes, sir. So no more questions.
All right. Thanks a lot then. Thank you.
Thank you, sir.
Thank you. Bye.
Thank you, sir.